Good evening, everyone. This is Veer Maheshwar Charitable Trust Latur MS India organizing daily international webinar series. This series is running from last 5 years, and speakers are invited from India and abroad. Every day we are enriching in the knowledge from the speakers on which they are delivering their topic as per their field of interest and research. Today, on 26th May, we have invited Miss Sabitha M G ma'am, who is Assistant Professor Artificial Intelligence and DS Department from Adishankara Institute of Engineering and Technology, Kalady, Kerala. The topic is democratizing, democratizing AI, create smart applications without the coding. I welcome you, ma'am, from this organization and from all the participants. As Adishankara Institute of Engineering and Technology have supported to us, various speakers have accepted our invitation and joined here. Mostly they are delivering the topic on the technical issue and important subject like AI. So today's topic is related to AI, and I request you, I welcome you, ma'am. You can start your speech now. Thank you.
Okay, thank you, sir. Thank you for your invitation. Good evening, everyone. I am Sabitha M G, Assistant Professor in the Department of Artificial Intelligence and Data Science at Adishankara Institute of Engineering and Technology, Kalady. Welcome to today's webinar, and the topic is Democratizing AI, Building Smart Applications Without Coding. Artificial intelligence is transforming industries worldwide. Traditionally, building AI solutions required programming expertise, knowledge of machine language algorithms, and significant technical resources. However, today we are witnessing major shift where AI technologies are becoming accessible to everyone through no-code and low-code platforms. Because in over last years, only the technical equipped people can develop applications. But recently, a drastic change got occurred. Even basic knowledge in the domain can develop applications. Only domain knowledge is necessary, and all the citizens can develop applications without expert knowledge in programming. In this section, we will explore individuals with little or no programming expertise can build intelligent applications using powerful visual tools such as N8N and Orange data mining. We will also see a practical machine learning workflow using linear regression and discuss real world applications across industries. Let us begin by understanding with democratizing AI what really it means. Moving on to the next slide, it will convey the agenda in today's webinar. Before we start, let me outline the today's agenda. First, we will understand the concept of democratizing AI and what it is becoming increasingly important. Next, we will discuss the rise of no-code and low-code AI platforms and how they are changing software development. Then we will explore N8N. It is an open source workflow automation platform, including its basic structure and working principles. After that, we will move to Orange data mining tool. It is a visual machine learning platforms that enable users to build predictive models without writing code. Then we will perform a linear regression demo using Orange data mining tool platform. Finally, we will examine real world industry applications and conclude with key takeaways and future opportunities. By the end of this webinar, you will understand how AI development is becoming accessible to everyone. The term democratizing AI refers to making artificial intelligence accessible to wider audience rather than restricting it to data scientists and software engineers. Historically, creating AI system requires expertise in programming language, algorithms, data pre-processing, and model deployment. Today, visual development environments allow users to build intelligent applications using just drag and drop interfaces. There are three important concepts shown here. The first one is no code platforms, where users can create applications entirely through graphical interfaces without writing even a single line of code. The second one is low code platforms, which provide visual developments while allowing optional scripting for advanced customization. And the third one is AI for everyone, where machine learning capabilities can integrate it through pre-built models and automated workflows. What workflow means, if we want to perform a particular task, the task can be divided into sequence of subtasks. The sequential collection of these subtasks form a workflow. The shift empowers educators, healthcare professionals, business analysts, and entrepreneurs and researchers to solve problems using AI without needing extensive technical backgrounds. Now, let us understand why democratizing AI has become so important. While looking into the slide, 70% of development time can be reduced by using this type of no-code and low-code AI platforms. Then 500 million people, they have basic knowledge such as citizen developers can build this type of platforms without expertise in programming languages. Organizations today operate in highly competitive environments and need rapid innovation. Traditional software development often requires months of planning and implementation. Research indicates that low code and no code platforms can significantly reduce development time and enable faster prototyping. The growth of citizen developers, that is, people who create applications without formal software engineering background, is called citizen developers. They can accelerate worldwide by using no code, low code AI platforms. Several key benefits include, by using no code, low code AI platforms, are faster solution development, reduced implementation cost, increased accessibility, greater organizational agility, improved collaboration between business and technical teams. Instead of waiting for dedicated development teams, domain experts can directly build solutions to specific requirements. This trend is fundamentally changing how organizations approach digital transformation. The democratized AI ecosystem consists of multiple categories of tools. The first category is automation and integration. Wide variety of tools are available in each category. In automation and integration category, we can use platforms such as N8N, Zapier, and Make allow users to connect applications and automate workflows. And the second category is AI and machine learning. Here, the users can use tools such as Orange, Google AutoML, and Teachable machines for simply developing a predefined model to create and deploy new models. For application development, which is the third category, here users can use platforms like Bubble, Glide, and AppGiver, enable users to create full applications visually. For analytics and business intelligence category, tools like Power BI, Tableau, and Data Robot provide advanced data insights. Today, our primary focus will be on N8N and Orange data mining, because together they demonstrate how workflow automation and machine learning can be combined to create intelligent solutions without coding. Let us now explore N8N tool. It is written as N8N, but it stands for node to node. Here, each task that has to be done can be represented by using workflow. As mentioned earlier, workflow is nothing if a user or a programmer can do a task, this task can be divided into n number of subtasks. This subtask sequential arrangement is called a workflow. In workflow, each subtask is called a node. Hence, it is called node-to-node interface. It is a workflow automation platform that enables users to connect different services and automate repetitive process through a visual interface. Some important features of N8N are: it is open source. It is self-hosted, or we can use cloud deployment. Both are possible. Then 400 integrations are possible in N8N. AI-enabled workflow support is provided. Visual workflow design, extensibility, all these are the important features of N8N. To understand N8N, we need to know few basic concepts. The basic concept are: first one is workflow. Already discussed what is workflow. It is a sequence of connected operations to perform a particular task. Then what is node? Node represents an individual action or task. Then the third one is a trigger. Trigger initiate the workflow. It is an event that starts the workflow. Then credentials. It means the passwords or API keys used for authentication information. The last one is execution. It refers to a completed run of workflow. The workflow can be executed by using the execution step. These are the basic concepts used in N8N. Together, these components allow organizations to automate complex business process efficiently. Then next slide shows the basic structure of N8N platform. Every N8N workflow follows 4 stages. That is, the first stage is always trigger. Trigger is already mentioned. It is a start of workflow. It's an event. Trigger. Then the trigger is followed by fetch data, then transform, output. These are the 4 steps used in the N8N workflow. Then trigger already discussed. It is example for trigger is submission of a form. When a new employee joined in a company, the HR manager will give some welcome message, share the salary details, create new email ID for the employee. A sequence of tasks is carried out to when a new employee is on board into a new company. These tasks can be automated using N8N. Then trigger in this case, in case of new employee joining a company, in this case, trigger is when the employee submit details of their details. This after submitting this form, a trigger will be created. Then the next step is fetch data. That means it retrieve information from APIs, database, or external applications. Then the data fetched from the database or external applications are transformed to some kind of processing. That is called transform phase. After transformation, the last phase is output. For example, output is in case of employee onboarding, sending a welcome message to a new employee is an output. This is the basic structure of N8N workflow. This is a sample workflow I had created in N8N. Now look at this simple workflow in N8N. As shown on the screen, the workflow consists of 4 main components. It is connected sequentially. First one is the trigger node. The workflow begins with a trigger node. In this case, when the trigger node is created as when clicking execute workflow. Execute workflow is a button, a red color button shown at the bottom of the window. When clicking on that button, the trigger will be initiated. In this example, the trigger is clicking on the button. This is a manual trigger which is used for testing purpose. In real world applications, as mentioned earlier, trigger may be a form submitted by a new employee or student submitting a form, incoming emails, webhooks, etc. are examples for trigger. Then the second step is HTTP request. In this sample, N8N workflow, actually an API, an open API, joke API is used. There are two types of jokes. For example, let's say general joke or a programming joke. General joke is like, for example, why Math's book is so sad. Then the joke is because the Maths book contains so many problems. This category of joke belongs to general joke. In case of programming joke, for example, why programmer like dark mode? Because the joke is light attract bugs. These jokes are created by the joke API platform. So in this example, an open API joke is used, and these jokes are randomly get from the APIs. And then the third node is if node. The jokes, either it may be a general joke or it may be a programming joke. Then and the third step, that is in if node, the joke will be checked whether it is a programmed or it is general. Then the if node will generate two outputs, either true or false. If it is true, it will be one kind of joke. It may be a programming joke. Then the corresponding action of programming joke will be performed. And the other case, it will be a general joke. Then that case, general programming joke actions will be performed. The last step is output. That is the output corresponding for each case. That is for general case and the programming case will be handled. For executing the workflow, step 5, execution and monitoring. Execute workflow button is clicked. These steps, 4 steps are executed one by one. First, the trigger is initiated. In second step, HTTP request is sent to the joke API and receive a particular joke from that API and send it to the if node. Then if node will check whether it is a programming joke or general joke, and according to the output will be generated. This is sample workflow created in N8N. And in the right side of the window, sample generated window, there is a plus symbol. By clicking on the plus symbol, you can create new nodes. Next platform, no-code platform is Orange Data Mining Tool. It is used for developing machine learning models by just drag and drop facilities. Orange is a free open source visual programming environment for data science and machine learning. The core philosophy of Orange is that machine learning should be explainable, visual, and accessible. Users build pipelines by connecting widgets. Each node in the Orange data mining tool is called widgets. Each widget performs a specific task, such as loading data, training the model, or generate a chart. These tasks are performed by each individual widgets. Orange support different types of machine learning algorithms, such as supervised and unsupervised. Again, in supervised learning, it supports regression, classification, and in unsupervised learning, it supports clustering. All these algorithms will be supported by Orange data mining tool. Let's move on to the next slide. This provides a visual overview of the Orange Canvas environment. Canvas is nothing where a user can create a workflow. Okay, actual working is carried out in the Canvas. The interface consists of 3 main areas in Orange tool. The toolbox on the left side contains all available widgets organized by categories. The canvas is at the center of the orange data mining tool, which is the working area where workflows are built. And the workflow itself is a connected graph of widgets that represents the entire data analysis pipeline. This slide focuses on Orange Canvas interface in detail. The toolbox on the left side of the data mining tool can be categorized by functional categories. Data for first one is data category. Data category belongs to loading the input to the model from the file, from the database, from SQL. All these data input categories are in data 2. Then visualize tool is there for scatter plot, visualization of data, different types of plots. Then third one is model. For developing a machine learning model, different kinds of machine learning algorithms. For example, linear regression, clustering, hierarchical clustering, classification, all these types of algorithms are available in model category. And the last one is evaluate. For performance evaluation, different types of widgets are used. The fundamental mechanism in Orange is a widget and the link. Widget is the basic unit of creating a workflow, and each widget is connected by a link. Then the link consists of left end an input and the right end output. Then each widget have both input or output or input. A widget is self-contained computational unit. It takes specific inputs, perform an operation, and produce specific outputs. For example, a linear regression widget accepts a dataset as input and produce a trained model as output. Links are then lines between the widgets that carry data from one to next. The input-output architecture makes Orange extremely modular. Any widget can be swapped out for another compatible one without rebuilding the entire pipeline. If instead of using Orange data mining tool, one is using a Python programming language, if some modification is required, the line of code have to be changed and then we have to re-execute the program. But instead of using Python, one is using Orange data mining tool. Just we have to change the widget and the connection link. Just a single seconds, we can update the programming language models. These slides categorize the full range of widgets available in Orange. Already said, the widgets are the basic building blocks in Orange data mining tool. Different categories of widgets are available. The first category is data input. For the machine learning model, the input is given by data widgets. Different types of input categories are available. For example, file widget, SQL query, and built-in dataset library, etc. are example for data widgets. The second one is pre-processing widget. For giving an input, there is n number of columns are there. If the user want to select a particular set of columns from there, we can use pre-processing. Appropriate number of columns can be selected. These pre-processing widgets are available. For example, select columns, impute for handling missing values, etc. are pre-processing widgets. And the third one is visualization widgets. The data available in Orange in platform can be visualized using visualization widget. Different type of visualization are scatter plot, box plot, heat map, etc. Then the fourth one is model category. Model category means different types of machine learning algorithms used. Just writing enter code in Python for linear regression, clustering, classification, we just add a single widget for machine learning algorithm. The model consists of different categories such as linear regression, decision tree, neural network, etc. Then the last one is after developing a machine learning model, we have to evaluate whether the model will perform good or bad. The different types of evaluation metrics can be used. For this evaluation, the widgets are test and score, confusion metrics, ROC curve, analysis, etc. can be used. These are the different categories of widgets used in Orange data mining tool. Concluding the widgets, they are data widgets, pre-processing widgets, visualize widget, model widgets, and evaluate widgets. At the end of this section, I will show a demo program in Orange for linear regression. For this linear regression demo, I am using a employee data set. 30 employees details, employee ID, and year of experience and salary. These details are considered, and based on year of experience, salary is predicted. So here prediction is to be done. So we use the model linear regression. Next slides will show the details of demo that is to be done. These are the workflow steps for doing the demo. As mentioned, I am using an employee data set. It contains 3 columns: employee ID, year of experience, and salary. 30 employees details are given, and after developing the model, I will give a test data. 9 employees, year of experience only give. Then the model will automatically predict the salary. The steps for developing workflow in Orange is dataset employee dataset is used in the first step, and the dataset contains experience and salary. The target variable used here is salary, and the input used is year of experience. First step for this workflow is load the input for the model. In this case, I am giving the employee details as a file. So for giving an input, file widget is used. Then I can visualize the what data in the file by using data table. Then pre-processing is carried out. 3 columns are there, but in regression, I need only year of experience as input and salary as output. So I perform some kind of pre-processing, I am selecting only 2 columns among the 3 values. That is, the 2 columns are year of experience as feature and salary as the output. This is the sample data set. I will give 30 employees and 2 columns, year of experience and salary. Here input is year of experience and salary is the output. The next slide will show the workflow in Orange data mining tool. The diagram illustrates how raw data enters into the pipeline. I will give the data set of employee, and then pre-processing is carried out. That means out of 3 columns, only 2 is selected. 1 is set as feature, and the salary is set as target. Then I will feed that selected column into a machine learning model. The machine learning model used here is linear regression model. And predictions are to be carried out. I will give, for predictions, I will give a test data of another 9 data, year of experience of 9 employees. Then the model will automatically predict the salary of that 9 employees. This is the actual workflow I have created in Orange data mining tool. This slide presents the complete Orange workflow for linear regression as it appears on the canvas. This is what participants will replicate during after the session. I will show the demo of this program. You can do it by yourself. The workflow is intentionally minimal. 7 widgets, 6 connections, and complete machine learning pipeline that goes from raw CSV to actionable predictions. The simplicity of this workflow is demonstration of democratization. A process that would take dozens of lines of code in Python is accomplished here. Visual interface that can be understood at a glance. Instead of writing thousands or hundreds of lines of code, just drag and drop the widget in Orange data mining. One can develop a machine learning model within minutes. This is a direct comparison between Python-based traditional approach and Orange no-code approach shown side by side. Every row in this table represents a stage in the machine learning pipeline. In every row, the Orange approach achieves the same outcome with significantly less technical overhead. This is not a claim that Orange replaces Python for all cases. When comparing the Python and Orange data mining tool, the development time is minutes, but in Python it may take hours. When modification is very easy in case of Orange, just drag and drop the appropriate widget is needed. No need for reconstructing the entire workflow. But in Python, a one mistake is eliminated by rewriting the code executed and this process is repeated until required output is generated. Then the last slide represents the applications of democratizing AI. First application is in healthcare. Automated appointment reminders and patient risk prediction can be carried out in case of healthcare applications. In e-commerce, inventory management, order processing, and demand forecasting can be carried out. In education purpose, it can be done by automated enrollment workflows, student performance prediction, etc. In finance, fraud detection, risk scoring, compliance automation can be carried out in case of finance. In agriculture, smart irrigation systems and crop yield forecasting. In human resource, resume screening, interview scheduling, and employee retention analysis. These examples demonstrate that democratized AI is not limited to technology, it can create value across nearly every sector. Before concluding, let us summarize the key message from today's webinar. First, AI is becoming accessible to everyone through no code and low code technologies. Second, N8N enable powerful workflow automation by visually connecting applications and services. Third one is Orange data mining tool simplifies machine learning by transforming complex analytical process into intuitive visual workflows. Fourth, the future belongs to citizen developers who combine domain expertise with AI-enabled tools to solve real-world problems. Only domain knowledge is necessary, then one can develop any kind of applications by using no-code, low-code platforms. Expert knowledge or programming knowledge is not necessary. The goal is not merely to use AI, but to empower more people to innovate using AI. We have reached the end of the presentation. Thank you all for your attention and participation. I hope this webinar has provided useful insights into how AI technologies are becoming more accessible through low-code platforms. You can download no-code and low-code platforms. Orange platform can be downloaded from orangedataMining.com and N8N can be downloaded from N8N.io.
Thank you, ma'am, for informative and useful speech within a best PPT and within a specified time. It was the democratizing AI and creating the smart application without the coding, without the machine language knowledge, or without a deep language, one can develop the application. Thank you, ma'am. for accepting our invitation and joining here. Now I request all the participants they can unmute and ask the questions or discuss with the speaker. Today we welcome our new speaker, which is new speaker for our session. She has joined just now. I think she has left. Manshi Soni, madam. I welcome you, ma'am. And I request participants to unmute themselves and they can discuss with the speaker. Thank you. I will share the feedback link for the participants. They are requested to fill the feedback link and issue their certificates. Those who are from engineering side here, they can discuss with our speaker. Feedback link is available in the chat box. All are requested to fill the feedback link and issue their certificates. Participants are requested to unmute themselves and they can discuss with our speaker. Thank you, Sabitha ma'am, for joining here as a speaker and delivering the best topic for us. In future, you will be here on a new topic as the speaker, and you can prepare another topic because this series is running from last 5 years, and we need speakers to continue the series every day. So the speakers, those who have contributed here, I'm very much thankful to them. Also, they can contribute again as a speaker in future also. Thank you, ma'am. Thank you to all participants, those who are joined here. You are requested to fill the feedback link. There are 20 participants. They have joined here, more than 20 participants, and they are welcome and they are thankful from the organizing team. Thank you, ma'am. Thank you.
Thank you, sir. Thank you for this opportunity.
You can leave. Huh? No
Okay,
problem.
sir. Thank you.